Today in Lesson 10, we are going to be working on describing distributions. Example 1, describing distributions. In Lesson 9, Sabrina developed the mean absolute deviation, MAD, as a number that measures variability in a data distribution. Using the mean and MAD with a dot plot allows you to describe the center, spread, and shape of a data distribution. For example, suppose that data on the number of pets for 10 students is shown in the dot plot below. There are several ways to describe the data distribution. The mean number of pets each student has is 3, which is a measure of center. There is a variability in the number of pets the students have, which is an average of 2.2 pets from the mean, the MAD. The shape of the distribution is heavy on the left and it thins out to the right. So now we're going to work on some exercises. I would like you to complete exercise 1 now. Suppose that the weights of 7 middle school students' backpacks are given below. Fill in the following table. In Part A. Part B. Draw a dot plot for these data and calculate the mean and MAD. Part C. Describe this distribution of weights of backpacks by discussing the center, spread, and shape. Here are some notes that should help you understand your work from number 1. Number 2. Suppose that the weight of Alicia's backpack is 17 pounds rather than 18. A. Draw a dot plot for the new distribution. B. Without doing any calculation, how is the mean affected by the lighter weight? Would the new mean be the same, smaller, or larger? Part C. Without doing any calculation, how is the MAD affected by the lighter weight? Would the new MAD be the same, smaller, or larger? Here are some notes to help you review your answers for number 2. Number 3. Suppose that in addition to Alicia's backpack weight having changed from 18 to 17 pounds, Fred's backpack weight is changed from 18 to 19 pounds. Part A. Draw a dot plot for the new distribution. Part B. Without doing any calculation, what would be the value of the new mean compared to the original mean? Part C. Without doing any calculation, would the MAD for the new distribution be the same, smaller, or larger than the original MAD? Here are some notes to help you review the answers for question 3. Without doing any calculation for Part D, how would the MAD for the new distribution compare to the one in exercise 2? Here are some notes to help you review 3D. Number 4. Suppose that 7 second graders' backpack weights were in the table that follows. Part A. How is the distribution of backpack weights for the second graders similar to the original distribution for 6th graders given in exercise 1? Part B. How are the distributions different? Here are some notes to help you review your answers to 4A and B. Example 2. Using the mean versus the MAD. Decision making by comparing distribution is an important function of statistics. Recall that Robert is trying to decide whether to move to New York City or to move to San Francisco based on temperature. Comparing the center, spread, and shape for the two temperature distributions could help him decide. From the dot plots, Robert saw that monthly temperatures in New York City were spread fairly evenly from around 40 degrees to the 80s, but in San Francisco, the monthly temperatures did not vary as much. He was surprised that the mean temperature was about the same for both cities. The MAD of 14 degrees for New York City told him that on average, a month's temperature was 14 degrees above or below 63 degrees. That is a lot of variability, which was consistent with the dot plot. On the other hand, the MAD for San Francisco told him that San Francisco's monthly temperatures differ, on average, only 3.5 degrees from the mean of 64 degrees. So, the mean doesn't help Robert very much in making a decision, but the MAD and dot plot were very helpful. Which city should he choose if he loves hot weather and really dislikes cold weather? We're going to try to do some more decision making with mean and MAD right now. Exercise 5. Robert wants to compare temperatures for city B and C. Draw a dot plot of the monthly temperatures for each of the cities. Part B. Verify that the mean monthly temperature for each distribution is 63 degrees. Here are some notes to help you with your answers for number 5. Part C5. Find the MAD for each of the cities. Interpret the two MADs in words and compare their values. Here is your MAD for city B. Here is your MAD for city C. Number 6. How would you describe the differences in the shapes of the monthly temperature distributions of the two cities? Here are some notes to help you with your answer to number 6. Number 7. Suppose that Robert had to decide between cities D, E, and F. Where is he going to move? Draw dot plots for each distribution. Here are some notes to help you decide how to make a dot plot for city D. Here is city E temperatures dot plot, and here is city F temperatures dot plot. Part B. Interpret the MAD for the distributions. What does this mean about variability? Part C. How will Robert decide which city he should move? List possible reasons Robert might have for choosing each city. Here are some notes to help you with number 6. Actually, number 7, my apologies. This is the end of our EduCanon. Great job today.